So before we proceed on the antiderivatives, let us review first on the differentiation formulas. So let me discuss this shortly. One of the co-inventors of the calculus is Gottfried Leibniz. Used the notation, the derivative of f with respect to x. So that is what we call the Leibniz notation for the derivative. So if we write y is equal to f of x, the following are alternatives for denoting the derivative. So f prime of x is equal to y prime, which can be written as the derivative of y with respect to x is equal to the derivative of f with respect to x. So that is equal to the derivative of fx with respect to x. So we've known earlier that the derivative of a constant is always 0. That can be seen on the y-axis of our graph. So it will be a straight horizontal line as a constant value does not change with the change in the value of x on the x-axis. So the graph of a constant function fx is equal to c is horizontal line y is equal to the constant, which has a slope of 0. So the first derivative of f of x is equal to 0. So if it is only constant, there is no change. That is why the slope is 0. So in my previous video, we have the constant rule and power rule. So if f of x is equal to the constant, then f prime of x is equal to 0. If f of x is equal to x, then f prime of x is equal to 1. If f of x is equal to x squared, then f prime of x is equal to 2x. If f of x is equal to x cubed, then f prime of x is equal to 3x squared. And if f of x is equal to x raised to 4, then f prime of x is equal to 4x cubed. So let's write examples of derivative of a constant. So first, what is the derivative of y is equal to 4? So since 4 is a constant, its derivative is 0. So in symbols, because we used y, so y prime is equal to 0. Next, find the derivative of the constant function f of x is equal to 10. The first derivative of a constant function f of x is equal to 10 is f prime of x is equal to 0. Third, what is the derivative of f of x is equal to pi? So since we have the value of pi, which is constant, that is 3.14, its derivative is still 0. So in symbols, f prime of x is equal to 0. Next is the derivative of a power x raised to n. So the derivative of the nth power of a function is equal to n times the product of the n minus 1 power of the function and the derivative of the function. So na-explain ko lang itong constant rule and power rule. So this is the formula in power rule. So the derivative of x raised to n with respect to x is equal to the exponent n times the coefficient of the variable x raised to the power n minus 1. So let's try an example. So let's just pick one of these examples. Let's try letter B. So in letter B, that is y is equal to x raised to 1/2. So in this example, let us try to find y prime, or the derivative of x raised to 1/2. So y prime is equal to, let us use power rule. So 1/2 times 1x, or 1/2 times x, that is 1/2 raised to the power 1/2 minus 1. Always na magma-minus tayo ng 1 from the exponent after natin i-multiply sa x. So that is 1/2 x raised to negative 1/2. So since we have the negative exponent, write it in a radical symbol. So that is 1/2 times 1 over square root of x. So you can also study how to write variable with negative exponent into radical form. So we will multiply 1/2 times 1 over square root of x. So y prime is equal to 1 over 2 square root of x. So that is now the derivative of our y, which is x raised to 1/2. So I will still discuss to you the derivative of a sum. But if I were you, I prefer to use a power rule. That is the easiest way in finding the derivative of a function or y. So let's try to find the derivative of example letter B. So y is equal to x raised to 1/2 minus x raised to 1/3. So in letter B, so just like in power rule, we will multiply 1/2 by x, so that is 1/2 x, and then subtract 1 from 1/2. And so with the next term, so that is 1/3 x raised to 1/3 minus 1. So y prime is equal to 1/2 x raised to negative 1/2 minus 1/3 x raised to negative 2/3. So since again that is a variable raised to negative 1/2, then we will multiply 1/2 by 1 over square root of x. Also with the next term, so that is 1/3 times 1 over the cube root of x squared. So always remember that the exponent inside the radical symbol is the numerator and the cube outside the radical symbol is the denominator. And always remember, if that is negative, if it is put on the denominator, that will be positive. So yung aim kasi nito, bawal tayo magkaroon ng negative na exponent. That is why we are using radical form. So the final answer here is y prime is equal to, or the derivative, or the first derivative of y is equal to 1 over 2 square root of x minus 1 over 3 cube root of x squared. So next we have also the derivative of product. So again, I will just discuss derivative of product, but if I were you, I will just use the power rule because it is the easiest. I have example, find the derivative of y is equal to x squared plus 5 times the quantity x cubed minus 7. So x squared plus 5 is the first function, x cubed minus 7 is the second function. Follow this pattern in finding the derivative of a product. So y prime is equal to the first term times the derivative of the second plus the second term times the derivative of the first. So our first term here is x squared plus 5 times the derivative of second. So multiplied by x cubed minus 7 prime plus the second term. So the second term is x cubed minus 7 multiplied to the derivative of x squared plus 5. That is our first term. So y prime is equal to x squared plus 5 multiplied to the derivative of x cubed minus 7, that is 3x squared. Since 7 is constant, so is here the second term, that is x cubed minus 7 multiplied to the derivative of the first term, that is x squared plus 5 prime. So y prime is equal to 3x raised to 4 plus 15x squared plus 2x raised to 4 minus 14x. So y prime is equal to 5x raised to 4 plus 15x squared minus 14x. And lastly, we have the derivative of a quotient. So the derivative of a quotient of two functions is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. So let's have an example. Let us find the derivative of y is equal to 1 minus x squared all over 1 plus x squared. So our rule here, we have the y prime is equal to the denominator times the numerator prime, or the derivative of the numerator, minus the numerator times the derivative of denominator all over the square of denominator. So y is equal to 1 minus x squared all over 1 plus x squared. Let us take its y prime. Denominator is 1 plus x squared times the derivative of the numerator, that is 1 minus x squared prime, minus our numerator, that is 1 minus x squared, times the derivative of our denominator, that is 1 plus x squared, all over the square root of our denominator, that is 1 plus x squared squared. So y prime is equal to 1 plus x squared times negative 2x, that is the derivative of our numerator, minus 1 minus x squared times 2x, that is also the derivative of our denominator. So all over 1 plus x squared, or quantity 1 plus x squared squared. So that is y prime is equal to negative 2x minus 2x cubed, plus we distributed negative 2x to the term 1 plus x squared, minus also with the other term 2x minus 2x cubed, because we distributed 2x to the term 1 minus x squared, all over 1 plus x squared squared. So y prime is equal to negative 2x minus 2x cubed minus 2x plus 2x cubed, all over 1 plus x squared squared. So our final answer now is negative 4x all over the square of 1 plus x squared.